Hello guys, my name is Lazaro and today we're going to be doing a LeetCode problem. This problem is called House Robber. You're a professional robber planning to rob houses along a street. Each house has a certain amount of money stashed. The only constraint stopping you from robbing each of them is that adjacent houses have security systems connected, and it will automatically contact the police if two adjacent houses are broken into on the same night. So this is a very important constraint to this problem. Given an integer array, nums, representing the amount of money each house, the amount of money of each house, return the maximum amount of money you can rob tonight without alerting the police. Now this is also a very important word right here, tonight. This represents that we're robbing all these houses all on the same day. So this constraint needs to be taken into account because it will only alert the police if it's on the same night. And so since we're all doing this on the same day, which we're told by the problem coding tonight, we know that we cannot rob two adjacent houses. And let's just see what's the maximum amount of money we can steal from these houses without the police being alerted. So now that we understand the problem, we can look at the first example. We have nums, which is 1, 2, 3, and 1. We cannot rob the 3 and the 2 because there are adjacent houses. And if we rob 2 and we rob 3, the police will be alerted and we would probably be taken to jail. So we don't want to do that. Instead, what we could do is rob 1 and then rob 3 because they are not adjacent to each other. And the max amount of money that we can get is 4. Here in the third example, we can rob 2, 9, and 1. Now the way they set up these examples, they made it look as you either want to rob every house in the even indices or every house in the odd indices, but that's not the case at all. Because we can have a nums array that is something like 4, 1, 1, 4. And what we want to rob is the first house and the last house. So this is a example that gives away the fact that we have to use not only a greedy method, but something more sophisticated, which in this case is dynamic programming. Now, dynamic programming breaks a problem to sub-problems and then finds the full solution by using a solution to those sub-problems. So it's a very efficient and optimized algorithmic technique. And I want to explain it in a mathematical format. I'm not really going to be doing a whole bunch of examples until we see the pattern. Instead, I want to look at it from a math standpoint. Now let's say we have some sort of house, let's call it f of x, where x is that house, or how many houses we've seen so far. Now for this function, for all these houses we've seen, or the houses in this location, whatever you want x to represent, the function is going to be equal to the maximum between f of x minus 2 plus f of x, or f of x minus 1. We can either rob this house, so take this house into account, and then also add the value of the house 2 blocks down or 2 rows down. The minus 2 just represents that it's not adjacent. So if we have an array like 1, 2, and 3, then our x is 3 in this example. We can take 3, as shown by here, and then add the house that's not adjacent, that's 2 blocks down, which is 3, and then plus the 1. So we can look at this 1 block and then 2 blocks down. Or it's the maximum between those two, or the one right before it, which is this 2. So this is the main function that builds out this problem, that represents the problem what we're trying to find. Now from this information itself, you guys might be able to build out a recursive solution to this problem since I did give you the recurrence relation. But I want to do this using a for loop, so just a simple iteration. So what can we notice from here? Well, if we want to use iterations, we first want to notice that this x minus 2 and this x minus 1 can be saved either in a separate array, or if we want to be memory efficient, we can simply use a variable. So we can use two pointers. Now let's draw this in different colors. Let's draw this x minus 2, or let's call this x minus 2 b, and let's call this x minus 1 a. Now I want you guys to now try to solve or see what a and b is equal to. And we can figure this out by just taking into account the next iteration, or the next house we want to rob. We can do that by looking at f of x plus 1. F of x plus 1 is equal to max of f of x minus 1 plus f of x plus 1, or f of x. Keep in mind this is the exact same thing. F of x plus 1 minus 2, where it's exactly what we did here, minus 2, is just x minus 1. So that's why instead of minus 2 I have minus 1 here. And here, instead of having minus 1, x plus 1 minus 1 is just x. So don't be confused and don't think that this is a completely different equation. It's actually the exact same thing, but I'm just taking into account the new argument for this function. Now realize that the new pointer, a, looks at what we previously solved. So let's give these a's some subscripts. If this was f of x, we can call this a of x, and respectively we can call this a of x minus 1. Now over here, this f of x minus 1, this is now our b, and we'll just give it the exact same subscript. Perfect. So now we can connect a couple of dots. Let's say if we want to solve what this a of x pointer really is, we can look at it in one way. We can say that a of x is equal to f of x, which in this case it is. And like how we have right here, f of x is just going to be equal to the max of b of x minus 1, so the previous b, plus the current value we're currently looking at, or the previous a, so a of x minus 1. Now what is b of x equal to? Well, b of x is, as you can see right here, is f of x minus 1, which is equal directly to the previous a of x. So b of x is always going to equal a of x minus 1. Now this is enough information to build out our two pointers. Let's say we have two variables that represents this a of x and this b of x. We can do this, we can carry this function as we're going through the loop. Now it was very important to do this second step so we can make the connection of what a of x is equal to. And then from there, we can make the connection that b of x is simply the previous a of x, which is a of x minus 1. So now let's do a small example with this. Let me first erase what we have up here. Let's say we had that example that break our assumption of just taking either of just returning the maximum of all the even indices added up or all the odd indices added up. And that example was 4, 1, 1, 4. It was this array. At the first index, let's do this by indices. So f of 0 is equal to the maximum of f of negative 2 plus f of 0 or f of negative 1. Now, of course, there is no negative 1, there's no negative 2, so this is simply going to be 4. So we can call this a of 0 is simply going to be 4. And since b of 0 is a of 0 minus 1, which is a of negative 1, and there is no a of negative 1, b is just going to be empty for now. So in this scenario, we really don't have a b. Our b comes into play once we've seen at least two numbers. So now let's do two numbers. So let's say a of 1 is equal to f of 1 plus max of, now f of 1 minus 2, and here this is where we would put that b of 0, but remember b of 0 doesn't exist. And that makes sense because the b of 0 would have represented f of negative 1, and that does not exist. So for now, let's just go ahead and put b of 0, but let's remember b of 0 doesn't exist, plus f of 1 or f of 0. And this f of 0 is represented by a of 0. This case is just the max. B of 0 doesn't exist, let's remember that. So it's just going to be the max between 1 and 4. In this case, it's 4. Now, our b does come into play, and b of 1 is equal to a of 0, which is 4. So far, everything we've done, we've been following this formula right here. Now, let's continue to the next iteration. A of 2 is equal to f of 2, which is equal to the max of b of 1 plus f of 2 or a of 1. This will be equal to the max of 4 plus 1 or 4. And of course, we would choose the 5 over the 4. Now b of 2 is equal to a of 1, which is equal to 4. This is getting pretty messy, so let me move some things around. Like I said, b of 2 is now a of 1, which was 4. Then a of 3 is going to equal f of 3, which is the max between b of 2 plus f of 3 or a of 2. In this case, this will result in the max of 4 plus 4 or 5. And of course, the answer is 8 because 8 is greater than 5. And then b3 is equal to a2, sorry about that, which is 5. And since we've reached the last index, because this is index 0, 1, 2, and then 3, we have stopped, and what we want to return is our a value, which represents all the houses or the maximum money we can obtain but by robbing non-adjacent houses. And that's it. This is exactly how you solve this problem, by just following this extremely useful formula. So now let's actually get into it and let's program it. Now, of course, we want to get rid of that problem where we're just looking at the first index, and b does not exist, and we can simply do that by just saying if the length of nums is equal to exactly 1, let's just return nums of 0. That's why, so we don't have to deal with any negative indices, and there's no problem that arises from that. Else, let's say our a is equal to the maximum between nums of 0 and nums of 1. And we're saying this because if there's only two indices, a will always be the greater integer within those indices, between the first one or the second one. And b, we can set that equal to the first. And the reason why we're setting it equal to the first is because we can call this b of 1. So when we're here, when we have two numbers, b is equal to whatever a of 0 was, and a of 0 is always going to be the first one. So that's why we set b equal to nums of 0. Now for I in range of 2 all the way to the length of nums, let's temporarily store whatever our a is. This will represent our last a. Let's call this last a. Now let's update our a. Our a is going to be the maximum between b plus nums of I, or the current a we're on, the current a we have. Again, that's following exactly this formula right here. And then b is equal to our last a. And then finally, let's return a. So let's run this code, make sure it works. It does. I tried a couple of test cases right here. Now we can submit. And it gets accepted perfect. So hopefully you guys can see how for dynamic programming questions, you guys really have to sometimes find that recurrence relation. And in this case, that's exactly what we did. We found this extremely useful function. And although we were able to do it recursively with the first function I showed you guys, we were able to boil it down in a manner where we can simply use two variables, in this case called a and b, to solve the question. So hopefully this helped you guys solve the problem. If it did, please leave a like and also consider subscribing. Other than that, thank you guys for watching.